In the beginning, there was darkness, and then, bang, giving birth to an endless expanding existence of time, space, and matter. Now see further than we've ever imagined, beyond the limits of our existence, in a place we call the universe.
In the distant corners of our solar system, ice giants Uranus and Neptune are violent worlds. Blanketed with smoky hazes, these outer planets are frenzied, turbulent, and unpredictable. Neptune claims the fastest winds in our solar system. Like an apparition, its great dark spot surfaces and vanishes without warning. Uranus's inner swarm of moons dash around the planet in less than a day, and collisions are unavoidable. The most controversial of the far-off planets isn't even a planet anymore. So why was Pluto demoted? The man who killed Pluto makes his case as we explore the outer planets. Meet the man who killed Pluto.
Pluto had it coming for a long time.
Caltech astronomer Mike Brown set in motion a chain of events that reduced the long-established number of planets in our solar system from 9 to just 8. Yet he feels no remorse.
There was no way that Pluto could survive its status as the single lonely ice ball, but it was gonna fall, and it certainly fell.
Among our planets, Pluto was long considered to be a bit different. Much smaller than the rest, it has the largest moon in proportion to its own size. It also has the most inclined and eccentric orbit.
Its orbit is sort of shaped like an egg. Pluto's orbit causes it to get significantly closer to the sun and then further away from the sun.
This cosmic needle in a haystack eluded planet hunters for decades. The eighth planet, Neptune, had been discovered in 1846, and astronomers at the turn of the century were convinced there was a ninth planet in the far reaches of our solar system.
The search for Pluto was started by Percival Lowell at Lowell Observatory. He thought there was a planet X there that was perturbing the orbits of Uranus and Neptune.
Before finding the elusive planet, Lowell passed away. But the observatory's research assistant, Clyde Tombaugh, continued his quest. In 1930, at the age of 24, Tombaugh captured an image of an object that seemed to validate Lowell's predictions. The discovery was announced to the world, and the object was given an official name, Pluto. But was Pluto Planet X? Some scientists argued that Pluto was far too small and didn't have enough mass to significantly perturb the orbits of its neighboring gas giants, Uranus and Neptune. Astronomers have since realized that there is no such Planet X. It had been predicted using inaccurate estimates of Neptune's mass. Even though Pluto wasn't Planet X, could it still be classified as a planet?
The first term for planet just meant wanderer in the sky. It was the things that moved relative to the stars. So to the ancient Greeks, the moon was a planet, the sun was a planet, the earth was not.
Of course, when we realized that the earth is actually going around the sun and that the moon is going around the earth, the definition of planet changed again. Earth became a planet, the sun and the moon were taken away, and there were finally 6. And over time, Uranus was discovered, and Neptune was discovered, so there were 7, there were 8.
Although it later proved to be smaller than our moon, Pluto was originally thought to be as large as Mars. So Tombaugh's discovery was anointed as planet number 9.
No one really thought much else about it. It was a strange object. It was sort of this lonely oddball at the edge of the solar system, but nothing else to call it, so it was called a planet.
Because of its great distance from the Sun, Pluto takes its name from the Roman god of the underworld. At its closest, Pluto is 2.7 billion miles from Earth. Its diameter is 1,485 miles, half the width of the United States. It takes 248 Earth years for Pluto to orbit the Sun. And a day on the planet is equivalent to about 6.5 Earth days. A 150-pound Earthling would weigh only 10 pounds on Pluto. It's a testament to modern technology that we know anything at all about the surface of Pluto.
We can hardly see this thing. Even with the Hubble Space Telescope, we get maybe 4 pixels across, maybe 12 pixels total. But even with that, we see that parts of Pluto are as dark as coal and parts of Pluto are as bright as snow.
Even from afar, scientists can measure the composition of the planet. They believe that the bright areas of the surface are made up of 3 types of ice.
Well, one is carbon monoxide, one is methane, which is the same as natural gas. And then the third is nitrogen, the same stuff that we have breathing here in our atmosphere.
The dark areas are probably solid rock.
The darker areas are almost certainly silicates of some sort. Silicates not unlike the rocks that we see here. That means there's silicon in them and there's oxygen in them. We're up here in Rocky Mountain National Park in Colorado. There's some snow around, there's some rocks around. This is similar to what we're going to see on the surface of Pluto.
A traveler to Pluto would find that despite the snowy surface, it is a very dim place.
About 30 or 40 times further away from the Sun than the Earth is. This means that the sunlight hitting the surface of Pluto is about 1,000 times fainter than it is on the Earth. It's maybe about the same brightness as being outside under a dim street light at night. You could probably, you could take a book, you could probably read it there. Take a headlamp though, take a flashlight, it'd help out.
Its distance from the Sun also makes Pluto one of the coldest places in the solar system, with a bone-chilling average temperature of -388 degrees Fahrenheit. And because of its small size and low density, gravity on Pluto's surface is far weaker than on Earth.
Now, some things are going to be a little easy to do on Pluto if you're really into rock climbing. I'm doing some vertical climbing here. Well, it's always exciting, but gravity is always the challenge.
Pluto's gravity is roughly 1/15 of the Earth's.
It's not like if you're standing on the surface, you would float away. Now, if you fell off that face when you were climbing up Pluto, you'd still want to have your rope there. You'd still accelerate down to the surface. So don't leave the rope at home.
Scientists would love to chip away at the surface of Pluto, because hidden within its rocks is a whole missing chapter in the history of our solar system.
Pluto's a great planet. I mean, it's what I think is really great about it. It's sort of the ultimate time machine in our solar system. It really shows us what the environment of the solar system was like 4.5 billion years ago when it's formed. The surface there is much more ancient than you're going to find almost anywhere else in the solar system. And if you're looking for rock on the Earth has been around for that same time period, 4.5 billion years or so. But if you're looking for rock that's that old on Earth, you're not going to find it. And that's because the Earth is sort of constantly recycling its material. You have plate tectonics going on that sucks all this material back into the mantle. You have volcanism going on that pumps out new material and processes the surface. So it's really a much younger surface on the Earth compared with the ancient surface that we're going to see on Pluto. The rocks that we're sitting on here have been processed by the high pressures in the Earth. On Pluto, it's more primitive.
Primitive, but far from pristine. Pluto is likely riddled with impact craters.
Impact craters are caused by asteroids or meteoroids impacting the surface. These are essentially pieces of the solar system that were never made into planet. Out of the surface of Pluto, you don't have an atmosphere, you don't have glaciers, you don't have winds, you don't have rain, you don't have erosion. And so the one dominant feature that you see on the surface is probably going to be a lot of impact craters.
Pluto's pockmarked surface undergoes a transformation as it orbits near the Sun. Under the additional heat, some of the frozen gases evaporate to form a temporary atmosphere. As Pluto recedes from the Sun, the gases freeze again and fall back down to the surface. For more than 75 years, this far-out icy object staked its claim as our 9th planet. So why is this little piece of snowy rock now causing such controversy? Why was Pluto kicked out of the solar system's most exclusive club? It's a quiet office at the Caltech campus in Pasadena, California. And it was from here that Pluto's demise as a planet began. But astronomer Mike Brown was never looking to destroy a planet. Equipped with Palomar Observatory's 48-inch telescope, he was seeking out Pluto-sized worlds at the far reaches of our solar system. And in 2005, he found one, an object bigger than Pluto, with its own moon, both orbiting the Sun.
When I first found this thing that's bigger than Pluto, I was looking through the images that the telescope had taken just before, and I found it in the screen. And did a very quick calculation, realized it was bigger than Pluto. And the very first thing I did was picked up the phone and called my wife and told her I just found a planet.
Indeed, if Pluto was a planet, and for more than 70 years it had been, then why wouldn't Brown's new world be considered a planet too?
I thought it was the 10th planet. For a long time, that's how I described it. It was a planet, and so I definitely felt like I had found the 10th planet. It's 5% bigger than Pluto. It's probably made out of the same materials on the inside, rock on the inside, ice on the outside, and a little thin layer of frost on the very outside that sometimes puffs up into an atmosphere and sometimes doesn't. Very similar to Pluto in that way. It has a moon that goes around it once every 16, 17 days. Pluto has a moon also, so it's, in many ways, I like to think of it as almost as twins. This is just the twin that just ate a little bit more when it was a baby, got a little bigger.
Brown considered naming his object Xena after TV's warrior princess, but eventually the name chosen was Eris, after the Greek goddess of discord. As it turned out, this name was entirely appropriate. The discovery kicked off a firestorm in the astronomical community. Now, the very definition of a planet was being hotly debated. Would Eris officially become our 10th planet, or would Pluto-sized objects be reevaluated as a whole? The argument was brought to the table in a 2006 meeting of the International Astronomical Union in Prague. a vote was taken and the term planet was defined scientifically for the first time.
Those who are in favor of Resolution 6A, which introduces this new category of trans-Neptunian objects with Pluto as a prototype.
The recommendation is that we consider Pluto and other similar trans-Neptunian objects to be in a special class.
We didn't reconsider Pluto's status because we learned anything new about Pluto that made it less interesting.
Instead, scientists say the issue was addressed because they learned about Eris and other large Kuiper Belt objects. The Kuiper Belt is a 3.5 billion mile wide region in the outer solar system near Pluto. It's home to hundreds of thousands of icy objects, the first of which was discovered in 1992.
So historically, we've thought of the outer solar system where you've got Uranus and Neptune out there. There are these big gaseous planets, giant planets. And then just beyond that, you've got this little straggler, Pluto, that doesn't really fit into the picture. Well, now when we found all these other Kuiper Belt objects, what we're seeing is that maybe Pluto is really just the first of these many, many bodies of the Kuiper Belt that are this wide diversity of small icy bodies at the outer solar system.
The result of the IAU vote stipulated that a planet is a spherical object that orbits the sun and clears out the neighborhood around its orbital path. Since the area around Pluto is full of other Kuiper Belt objects, the new definition would leave Clyde Tombaugh's great icy discovery out in the cold. Pluto's 76-year reign as the 9th planet was over. Our solar system would now officially consist of only 8 planets. Objects like Pluto and Eris were given the new classification, dwarf planets. Dwarf planets possess the same characteristics as planets, but do not have a clear orbital path. Under the new definition, Ceres, the largest asteroid in our solar system, is also a dwarf planet.
We have this new terminology because there's more things in the outer solar system than we used to think. It's like all you could see is one skyscraper, and now all of a sudden you have a whole city in front of you. We have a whole city full of objects in the outer solar system now.
The IAU vote was meant to settle the debate on what constitutes a planet, but many scientists refuse to accept the outcome.
There are astronomers who want it to be a planet still, and they just keep ripping those scabs off whenever possible, and they want to keep it fresh.
I believe Pluto is a planet. And I don't think the question of whether or not Pluto is a planet is really that important. Fundamentally, it's not a scientific question, it's a question of names. But in a way, in an odd way, it's become one of the highly visible subjects of planetary science.
People always ask whether Pluto is a planet or not. There's not one easy dividing line. There's one not where you move from being a planet over here to being a planet over here to being not a planet over here, just like there's no real dividing line between a stone and a pebble. It's really more of a sociological question. It's a question of definitions of words rather than a question of science.
Although no longer officially a planet, scientific interest in Pluto hasn't waned. Even as the vote was being taken in Prague, a NASA spacecraft called New Horizons was already on its way to exploring this far-off world. The New Horizons mission will be the first spacecraft ever to visit Pluto.
By going to Pluto, studying Pluto, it's no longer a mission to a singular object, but it's actually a mission to one of a class of objects that we'll get to learn about.
But New Horizons needs to travel at warp speed, or a valuable research opportunity to study Pluto's atmosphere will be lost for at least the next 200 years. The New Horizons spacecraft is headed for a rendezvous with Pluto.
We have confirmation of spacecraft separation.
But scientists are trying to beat the clock. Because as Pluto recedes from the sun, its 62-year-long winter is coming. And when winter comes to Pluto, the dwarf planet's atmosphere will freeze and fall to the ground.
If it collapses too much, it might just be a lot less interesting. You might not have as interesting chemistry. And we want to know what the temperature and the composition and the structure and the winds on the atmosphere.
To get there in time, New Horizons is blazing through the solar system at more than 45,000 miles an hour. That's 12 miles a second. At that speed, a trip from Los Angeles to New York would take about 3.5 minutes.
So this is the fastest spacecraft that was ever launched from the Earth. In fact, it took about 6 hours to get out to the 250,000 miles to make it out to the moon. You can compare that to the couple of days that it took the Apollo astronauts to get out that same distance.
New Horizons would pass by Jupiter in just 13 months. But the outer solar system is so big that it's going to take us another 8 years to get to Pluto.
Even with its unprecedented speed, New Horizons won't reach Pluto until July of 2015.
Pluto's just a big mystery. It's exciting to me that there's a spacecraft on its way there, and that in a few years we'll, this sort of blank slate of a world will be richly filled in with pictures and detailed data.
About 4 billion miles from Pluto, Uranus is a mesmerizing blue marble.
And it's really strikingly beautiful and different from the other planets. It's a giant blue, pale blue, fuzzy ball sitting there in space against the darkness of space. And it's just that striking blue color and the almost pure featurelessness of it. It seems unreal. It looks as though it was sort of created by some movie special effects person, because how could you have a planet that large and that perfect and just this giant featureless blue?
Uranus is 1.6 billion miles from Earth. It has a diameter of nearly 32,000 miles, 4 times Earth's diameter. It takes 84 Earth years for Uranus to orbit the Sun. 1 day on Uranus is a little over 17 hours. If you weigh 150 pounds on Earth, you would weigh 133 pounds on Uranus. Named after the Greek god of the sky, Uranus has the most off-kilter axis of any planet in the solar system. At an angle of 98 degrees, the planet is actually spinning on its side.
What that means is that at one time of the year, only one hemisphere is pointing towards the sun. The other hemisphere is complete darkness. The time for Uranus to orbit the sun is about 84 years, which means that for half of that time of 40 years, one hemisphere is in sunlight and the other hemisphere is in dark.
It's like the Arctic Circle on Earth, except for it's the whole planet. That tilt is so extreme that in a sense, the whole northern hemisphere is the Arctic, and the whole southern hemisphere is the Antarctic.
Uranus owes its cool bluish-green color to methane. The methane absorbs red and orange wavelengths from sunlight, but reflects blue and green. And its soft appearance is due to something that's familiar to anyone who lives in a big city: smog.
In Southern California, we're used to smog, which is photochemically produced haze material, which gives this hazy appearance in the atmosphere.
This is similar to the atmospheres of the 4 gas giants.
In the outer planets, there's methane, which is natural gas. Sunlight converts it to complex particles as well, which forms a haze, which is the reason the planets don't have a very sharp, but have a fuzzy look to them.
Scientists speculate that Uranus and its celestial neighbor Neptune formed the same way. As the early protoplanetary disk of gas and dust in our solar system settled, Jupiter and Saturn gathered up the most material and became the largest of the gas giants. As Jupiter and Saturn's orbits grew, they destabilized the planetary system as a whole. Dynamic interactions pushed Uranus and Neptune outward to the edge of the solar system at an accelerated rate, where they feasted on icy objects.
They have a lot of that initial gas, but they also gathered a lot of icy material and some rocky material in their formation. So consequently, although they have this surrounding envelope of hydrogen and helium gas and some methane, some nitrogen, some other stuff, they also have a lot of icy material in the inside.
These icy interiors have led some to call Uranus and Neptune the ice giants. But it's incorrect to imagine them as balls of solid ice that an astronaut could walk across.
Well, if we dropped an astronaut or a probe towards the center of Uranus or Neptune, well, first of all, they'd be in a lot of trouble. There's really no solid surface that they could stand on. There may be a small rocky core at the center of these planets, but the pressure that they would be experiencing from the atmosphere overhead and this liquidy, icy region would crush them. It would be millions of times the pressure that we have from our own atmosphere, for example. So they would be flattened well before they ever reach the solid surface.
While the other gas giants have wild weather patterns, Uranus seems to be relatively calm, and scientists think they know why.
Uranus is unique among the gas giant planets in that it is the only one that doesn't have an internal heating source. Jupiter, Saturn, and Neptune all have heat coming from deep within the planet, and that helps drive the circulation, and it explains why we see a lot of the banded structure that we do on those other three planets. Uranus doesn't have this internal heating source.
Uranus has another claim to fame, the way in which it was discovered by astronomer William Herschel in 1781. At the time, the only known planets were the 6 visible to the naked eye from Earth. But Herschel first laid eyes on Uranus through a telescope.
Herschel was an amateur astronomer, professional musician, and an optician, so he had the knowledge and ability to generate the best telescopes in the world at the time.
The discovery of Uranus was incredibly significant in the history of humanity because it was the first planet discovered by telescope, the first planet that the ancients didn't know about.
In 1977, NASA's Kuiper Airborne Observatory made another exciting discovery when astronomers aimed their telescope at Uranus. They were planning to watch a fairly common astronomical event, the passage of the planet in front of a star. But as Uranus closed in, the star suddenly winked. In fact, it seemed to flicker on and off 5 times as it neared the planet, and then several more times as it emerged on the other side. What was the cause of this strange phenomenon? The flickering star was actually passing behind 5 planetary rings, features that had only previously been seen on Saturn. Subsequent observations from the ground and then the Voyager spacecraft confirmed the ring's existence. And observations made in 2005 from the Hubble Space Telescope found a second set of rings orbiting almost twice as far away from the planet as the previously known rings. Unlike Saturn's thick icy rings, Uranus's are dim and thin, comprised of dark, rocky dust. Some of Uranus's dusty rings were likely formed by the impact of a meteor or a comet with one of the planet's 27 moons. The inner rings could be the result of collisions between the moons themselves, especially the 13 that orbit in the planet's kinetic inner swarm.
There are a lot of inner moons around Uranus, moons that are very small and close to the planet. They tend to have very fast orbits on the order of maybe a day.
Other moons zip around Uranus in just 12 hours. By comparison, our moon circles a planet 4 times as small and takes 28 days to do it. With Uranus's moons speeding around the planet like race cars, it's only a matter of time before 2 of them end up in another cosmic collision. Circling the planet Uranus is a swirling system of moons. Even within the last decade, substantial changes have been detected in their unruly orbits. Scientists believe it's only a matter of time before 2 of them cross paths.
We can be very certain that in a period of a million or a few million years, that some of them will collide with each other.
I'm thinking particularly of Cupid and Belinda, which are 2 small moons that happen to be orbiting very close to each other.
Traveling at just a few hundred miles apart, scientists expect that at some point, these moons, due to gravitational forces that they impart upon each other, will eventually collide and rip each other apart. It will be a bad day for the moons, but a welcome event for the planet's ring system.
The debris that's released from that can potentially generate a new ring around Uranus.
Uranus shares the outer solar system with its sister planet Neptune. A gleaming sapphire some 3 billion miles away from the Sun. With the demotion of Pluto, Neptune is now our outermost planet. Neptune takes its name from the Roman god of the seas. Neptune is 2.68 billion miles from Earth. Measuring roughly 30,000 miles, Neptune's diameter is 4 times that of Earth's. A year on Neptune is equivalent to 165 Earth years, and a day lasts 16.1 hours. If you weigh 150 pounds on Earth, you would tilt the scales at 169 pounds on Neptune. Like all the outer planets, Neptune rotates much faster than Earth, and this rapid spin helps to create violent winds.
In fact, the highest winds recorded on any planet in the solar system are on Neptune. You have winds of sometimes over 1,000 miles per hour, and commonly 750 miles per hour, raging in that upper atmosphere. And we're not quite sure why, so there's a little bit of mystery.
What puzzles scientists is why Neptune's winds blow even stronger than those on the other outer planets, with speeds 2 to 3 times faster than in Jupiter's blustery Great Red Spot. JPL researcher Michael Mishna studies what drives weather on other planets. He's intrigued by Neptune's mysteriously strong winds.
If we were to put one of these windmills up on Neptune, depending on the altitude that we put it, we would either see motion similar to what we see now, or if we were to place it at the altitudes in which the winds are going 1,000 miles an hour, we actually might not see very much motion at all. And that's because the atmosphere is so thin that there's just not enough oomph and not enough force from that wind to actually turn the propellers of the turbine. So you might not actually see any motion at all. On Earth, we see high pressure and low pressure systems if we look at weather maps, and the same to an extent can be seen on the outer planets. We can't exactly identify a big H in this location or a big L in this location. But there are generally regions that are warmer and have higher pressure than other areas which are colder and may have lower pressure, and that generates the winds that blow from high to low.
A key factor in the creation of wind is an energy source to heat the air. On Earth, the sun provides this energy. But the windswept planet Neptune is 30 times farther from the sun than Earth, and it gets only about 1/900th as much solar energy. It's simply not enough to power Neptune's colossal winds. Scientists believe that Neptune gets its additional power from within. Measurements taken by Voyager 2 showed that Neptune radiates twice as much heat from its interior as it gets from the sun. The highest ratio of heat outflow to inflow of any planet in the solar system.
Neptune has a relatively large amount of internal heating, which is coming from radioactive decay of materials inside and other chemical processes that are occurring, and that releases a lot of heat from the inside.
Just why the interior of Neptune generates so much heat remains a mystery. It's led some to speculate that the planet is still in the process of forming, and the infalling gases are releasing heat as they are compacted by gravity. This internal heat source could also explain the convection of gases in Neptune's atmosphere that leads to fascinating cloud patterns.
There are many bright white clouds that appear in the atmosphere. There are different regions of very bright and dark banding on the surface, so we'd be able to distinguish different latitudes by the brightness of the bands.
Scientists believe that the banding patterns have something to do with Neptune's cloud composition.
These are probably made of methane, and they move very fast around the planet as well.
Neptune's wind movement is unlike anything we are accustomed to.
These are giant storm systems. Storm systems that would dwarf anything that we see on Earth.
In 1989, Voyager 2 snapped a photograph that shocked the mission scientists. Neptune had a huge storm, a great dark spot in its southern hemisphere. Stretching 8,000 miles wide, large enough for our Earth to fit in the center, the storm resembled Jupiter's infamous Great Red Spot.
The Great Red Spot is a huge anticyclone, which is fed by many smaller storms that keeps it alive, if you like. Otherwise, it would dissipate and disappear. In the case of the Great Dark Spot, we believe it's more of an instability in the atmosphere, which rocks back and forth because of the flows in that very fast atmosphere.
Just 5 years after the spot was first discovered, scientists were in for another surprise. The Hubble Space Telescope turned its eye toward Neptune, only to see that the largest storm on the planet was gone. What happened to Neptune's Great Dark Spot? Within a span of 5 years, the largest storm on the planet simply vanished from the southern hemisphere. But that didn't mean the end of megastorms on Neptune. Astronomers using the Hubble Space Telescope observed that a new Great Dark Spot had appeared. But this time in the planet's northern hemisphere.
It seems that on Neptune, the storm systems that manifest as these big spots you can see with a spacecraft or a telescope, they sort of come and go on shorter time scales than, say, the Great Red Spot on Jupiter, which has been there for hundreds of years.
Not only are these storm systems transient, they're also eccentric. Scientists observed that the size of the Great Dark Spot oscillated by several thousand square miles within a span of just 8 days. The disappearance and reappearance and overall erratic movement make Neptune's storm systems some of the most unpredictable in the solar system. Similar to its outer planet neighbors, Neptune has a complex system of moons. 13 have been discovered so far. some of Neptune's moons may have originally formed elsewhere in the solar system.
Neptune's probably capturing these moons from the vast amount of material that's actually in our solar system beyond the orbit of Neptune and Pluto. There is a lot of very icy bodies, small bodies, planetesimals and other rocky things that pass through our solar system, and other debris. Every so often, some of this debris might collide with each other, and then they get pushed in towards the solar system.
Some of these icy bodies end up as comets. But if one is pushed in the right direction at the right time, it can be captured by a planet's gravitational pull, becoming a moon. Neptune's largest moon, Triton, is roughly the size of Earth's moon. It is the coldest object in our solar system ever observed by astronomers, even more frigid than Pluto.
Only 40 degrees above absolute zero, about minus 390 degrees Fahrenheit. So cold that the nitrogen, which would normally be in a gaseous form, forms an icy polar cap on this moon.
Triton's so cold primarily because the surface is so reflective. About 70% of the light that hits the surface of Triton is reflected back. And with that much light not being absorbed by the planet, it just gets very, very cold.
Triton could well be similar in composition to Pluto. We see ices on the surface there. One of the fascinating things that we see on the surface of Triton are actually plumes, essentially volcanoes. We see these plumes. We've actually seen them coming out in real time with the Voyager spacecraft when it went past Neptune and Triton.
Unlike Earth's volcanoes, Triton's geyser-like eruptions spew a mixture of liquid nitrogen, methane, and ammonia. And an upsurge instantly freezes as it rockets 5 miles high into its thin atmosphere. Once airborne, the ice can be carried along for miles by winds in the atmosphere before snowing back down onto the surface. Geological activity on Triton makes scientists wonder if there's water, perhaps being heated under Triton's icy exterior. And as the theory goes, where there's water, life could be present. If that's the case, Neptune's largest moon could be home to one of the biggest discoveries of all time. But due to planning and transit times, it will be at least 2 decades before we approach Uranus or Neptune again.
We've had discussions, but there are no current plans. We could with Voyager, where we just had a brief flyby, and we managed to collect a lot of discovery. But in fact, we need to get back to pursue those discoveries.
In the meantime, scientists will be focused on New Horizons as it rockets even closer to Pluto. On board, in addition to a cluster of scientific instruments, is a small canister of ashes. Those of Pluto's discoverer, Clyde Tombaugh, who died in 1997 at the age of 90.
I'm not involved in New Horizons missions at all, but I can tell you from my point of view why I'm very excited about it. We really don't have any good ideas of what the actual features on the surface of Pluto are going to be like. That's why these small-scale pictures, getting actual close-ups, is going to be so important.
As spacecraft, probes, and telescopes are sent to the far reaches of our celestial neighborhood, we come one step closer to deciphering the expansive universe. Our technology and our imaginations can help bring these far-off alien worlds to life. As we look at them with awe and wonder, we can only fathom what unexplored mysteries lie deep within.